We've got 10 scheduled Lightning talks. We'll hopefully get through them all in the time that we have, but obviously there's a lot of pressure on the AV people, so we're setting up multiple laptops and having to switch between them and things. In the past, many of you, who's seen me tell tractor jokes before? There we go. That is false enthusiasm, as anybody who's heard any of the jokes will know. Fortunately, we have 2 lecterns these days, and hopefully we'll have somebody setting up while one talk is going on, so we should minimize technical issues, which means that with any luck we can get through 3 days of this without me telling any awful tractor jokes. Oh, you don't mean that. So, let me just give a quick reminder. Lightning talks are 5 minutes long or less. I didn't make enough of a deal about that when I was talking about it in the opening session. You can give a talk for 1 minute if you like, if that's the right length for your talk. We actually love those kinds of talks because it usually gives us a bit more wiggle room to fit in the talks that we want to in the time that we have. If the speaker gets to 5 minutes, that's kind of the limit. That we can't fit in enough talks if people talk over, and it is kind of a natural thing to talk over. It's very difficult to get a talk down to 5 minutes, but we still like to be polite. If somebody gets to 5 minutes, I will raise my hand like this, and then I would all like you to tap 2 fingers together. It makes a slightly weird noise. If everybody could just have a go right now. There we go. So if you hear that, you basically have to finish your sentence. Once you get to the end of the sentence, I will raise both hands, and then the audience will erupt into a massive round of applause, stamping feet, whistling, whooping. If we could just have a quick go at that, that would be wonderful. And that, everybody, is why people give lightning talks. So we have our first speaker. On my left here, my friend Eli is going to give us a very quick talk about SHA-2 hashes. Take it away.
I've started my timer. Hello. Thank you, everybody, for staying for lightning talks and coming to hear me talk about hashes. So, who here uses hash functions in any part of their work? Yeah, lots of us. Cool. What is a hash function? Well, we deal with digital objects a lot, and often they're quite large. So this is a large digital object. Often, we'd like to be dealing with smaller digital objects, and to get there, we use hash functions. Hash function has some properties that we need to satisfy in order to be considered a hash function. It needs to be extremely sensitive to input, so a slightly different big digital object needs to produce a different smaller digital object. It needs to be cryptographically hard to reverse. This has a technical definition that I won't get into, but essentially it's a one-way function. And it has to always result in an object of the same size, regardless of the size of the big digital object. This is what makes it different than a compression function. So, there's some jargon to do with hash functions, and if you remember this jargon and use it correctly, you'll sound really smart in meetings. The smaller digital object is called a hash or a digest. So if you ever see people talking about message digests, that is to do with hashes of messages. 2 large objects that hash to the same thing is called a hash collision, and it's a way that these things can fail because we assume it never happens. People get very anxious about Git having hash collisions because they used to use SHA-1 for their commit hashes. This practically will not happen. You don't really need to worry about it, but it's very interesting to read about. And the way that these functions work, or at least the SHA family of functions work, is by breaking the input that you put in into equally sized blocks. So regardless of how big your input object is, it will break it into some equally sized number of blocks and process them essentially independently. This makes it faster to process because some of it can be parallelized, not all of it. So when you see people talking about blocks within hashing functions, that's what they're referring to. Why would we want to do this? Well, we like to be able to identify objects by their digests, and this is a very good, this is a thing we can do. We can get hashes use this. There's a thing called content addressable storage, CAS systems that use this. These are sort of quite niche these days, but they used to be like a big hype thing. And another big thing is for verifying contents of a big digital object. So if you send something and then you send its hash, I can check whether or not my version of it is the same by hashing it with the same function and then comparing the hash outputs. And it means I don't have to compare the objects, the original big ones, byte for byte. So the way that the SHA family of hash functions work is something called the Merkle-Damgård construction. And what it is we start with a compression function. And a compression function takes 2 inputs of the same size and outputs 1 output of that size. So you can either take two 128-bit strings and turn them into one 128-bit strings, or one 256-bit string and chop it in half, treat it as two. And this is not a hash function because it doesn't give you a constant sized output. The output size is dependent on the input size. But we can use them to make hash functions, and this is how we do it. We take a big digital object, we break it up into, let's say, chunks of 128 bits, and we pad to make it up to a 128-bit length. And then what we do is we feed it into a compression function over and over again. We take some initial values, and then we feed that and the first 128 bits into our compression function, get 128 bits out. Do it again, do it again, do it again. And every time we're updating the hash value that is the intermediate hash value that's completed at each of these stages. And at the end, we get an output that is of fixed size. And that is essentially how hash functions work. What we need to do to make sure that these things are able to be reproduced faithfully, because you want your SHA function that you're using to be the same as everybody else's SHA function that they're using, so that you can use it to compare hashes of objects. We use known constants for that. So tidbits about this. The known constants are actually fractional parts of square and cubic roots of the first however many prime numbers. This means that they're always computable from scratch. They're not just random numbers we plucked out of a hat and wrote down somewhere and then lost the piece of paper that we wrote it on, and we can now never recreate them. They are derivable from first principles. Trying to compute an input for a given output is called a pre-image attack. So if I have a given hash and I'm trying to find something that hashes to it, this is really, really difficult. It's easier, it's sort of twice easier to, well, not twice, it's a lot easier to try and find two things that hash to the same thing. This is called a birthday attack, due to the whole thing of there's only 23 people. If you have a group of more than 23 people, it's more likely than not that two of them will share a birthday. But it's only, you need 180 people before it's more likely than not that anybody had a birthday on any given day. With 8 seconds left to go, these are patented, but they're royalty-free, so I'm not breaking any copyright. Woohoo!
Thank you, Eli. It's always nice when a speaker manages their own time. And now, very quickly, I'm just going to introduce Lydia, who is going to give us a quick talk about long COVID and e-bikes. Take it away, Lydia.
Hello, everybody. I'm Lydia. I had COVID in 2020, in March, when it was young and fresh, and nobody knew a lot about it. And then I got long COVID. It was awful, and of course nobody knew about long COVID either. So I like to experiment anyway. So I ended up experimenting on myself, figuring out how to get better. One day I had a marvelous idea. It was my birthday, and I decided to get myself an e-bike. And let me tell you, anybody here that's had COVID and long COVID will know that your energy is really hard to manage. The lovely thing about an e-bike is that it gives you mobility and the ability to get back home when you get too tired, and that happens a lot. So, if you know somebody that has long COVID and is suffering and is not yet aware that e-bikes or any kind of motorization you can give yourself can really enhance your quality of life, please tell them. So that was one part of my message. The other part of my message is that I figured out that in order to manage my long COVID, I needed to measure what was going on. I have an Apple Watch. I'm not particularly fan of Apple per se, but any kind of monitor that helps you measure your heart rate and your oxygen rate, and it does not need to be accurate, because all you need to do is get a baseline, what is normal for you and what is okay for you, and then you need to notice that you're going significantly over that, and that can be 10 or 20 beats per minute, might be you're over. That really is a personal thing, but basically measuring is the key to monitoring your effort when you have long COVID. And if you monitor that, then you can make sure you stop doing whatever you are doing when you're doing too much. And that unlocked my ability to get back into normal life. I have a job now. I'm a developer again. I can go out and hike. I've climbed a Monroe again. And really, that was what I wanted to give the world. Just the knowledge that you can get there. There's hope.
Thank you, Lydia. This is the kind of mix of lightning talks that we like. So now I will quickly introduce Daniele, who is going to ask you, what is your favorite film? If we could get, there we go.
So my question is, what is your favorite film? So you think, sorry? So why is this man on stage asking fatuous questions? Of course you don't have one favorite film when there are so many different films to choose from. And they all have different characteristics and they're all suitable for different situations and needs. And you can like them all for different reasons without having a favorite. So Kodak Color Plus, don't expect delicate pastel tones. It gets muddy if you're careless with exposure. But I love how it renders blocks of striking color and you can get some beautiful detail from it. Or Ilford HP5, which is not smooth, it's gritty, but it's detailed and strong. It gives you an amazing range of shadow and deep blacks. I loved Agfa Photo Visa Plus. It was stunningly cheap. It was also unpredictable. You would never use it for portraits, but it loved light and it makes rich and vibrant colors. So it was my favorite travel film. At the other end of the price range is Kodak Portrait, which has this very fine grain structure. It's balanced and well modulated, and it produces beautiful natural skin tones. So that makes it perfect for photographing people. And when I say people, I mean white people. This is what's known as a Shirley card, named after the model Shirley Page. From the 1950s, Kodak would send negatives of this image to all their labs, along with really carefully produced prints, so that the labs could test and calibrate their own setups against this ideal result. It was a quality system to produce the best results at scale for white people's skin. And in fact, everything in photography, film formulations, lighting and darkroom practices, what they teach in photography schools, or image enhancement and facial recognition algorithms have all been premised on white people's skin. So what does it matter? Well, generations of black children have brought home disappointing school photographs, especially if they were the only black child in a classroom of white classmates. Or perhaps you've seen the funny videos of black people trying to use automatic soap and paper towel dispensers that only work for people with white skin. But a bit less funny is that low oxygen levels may be harder to detect in darker-skinned people using pulse oximetry, which is possibly why black children are 4 times more likely to suffer post-operative complications for certain procedures. Do you think this is funny? Here I am with my colleagues at a restaurant. There are 6 people in this picture, and one of them is completely invisible. And she's invisible because the expensive mobile phone with Hasselblad lenses and packed with facial recognition software literally fails to recognize black faces. So why does technology often seem to fail to account for the blackness of some people's skin? And I think one reason is because people with black skin are underrepresented in the design and manufacture of these technologies, while the effect of the failure is often only visible to those who are underrepresented in the first place. And I think there's a general rule that industries in which certain people are underrepresented tend to create products that disadvantage those people, because it's easier to forget about people when they're not there. So crash test dummies have been based on the average male Caucasian, whereas women are significantly more likely to be killed or injured in car crashes. It's not all bad news. Left-handed tennis players have an advantage over their more common right-handed opponents. But on the other hand, they are more likely to be killed or injured when using power tools, so I hope they enjoy tennis and it really matters to them. So in what ways that are invisible to us might the things that we make, our software products, disadvantage underrepresented people? And I don't know. which is the point. Because I probably won't know, even if I care and want to know, because it's likely to be hidden from me because I am not one of those people, and because underrepresented people don't tend to be in the room around me when the products are being made. So, how can we ensure that our products won't disadvantage or even harm some people? Because I firmly believe that however good our intentions, however firm our commitment, however clever we are, we will not succeed in making products that don't make some people invisible unless those people are actually present in the room where the products are being made. And that means this room, too. So my more serious question is, we're making software. Who is present in this room and who is absent? Thank you.
Thank you, Daniele. It's never a surprise to get an amazing talk from you. And now I'm going to hand over to a very different type of talk, I suspect. Anthony Harrison is going to talk about PEP 770.
Right, afternoon. Yes, this is a bit more techie, but I think it's just as important. Manchester, we have a problem. I don't mean why Man United can't score goals and why the blue is dominant, and that's what PEP is. It's when we do pip install. Because lots of magic happens. Like that. Do you read it? Does it happen does it happen the same time every time you do it? No. We have a dependency problem. We stopped writing software 20 years ago. We now assemble software using components. And Python's great at that. They come from third parties that we probably don't know. We trust them. We specify them in our code base, requirements.txt, etc. What we don't specify is their dependencies on those dependencies, etc., etc. And that means we don't understand our attack surface. And we all know the consequences of if we have software that has vulnerabilities, ask Marks and Spencer's. Because this is what we think we have, which is our direct dependencies, and then a few things appear underneath the hood that we don't watch. That's more likely. Probably 20 dependencies become 100 packages. Think about how much code that is. Why does this matter? I'm in cybersecurity. I can't secure what I don't know. You can't secure what you don't know as developers, as organizations. We need more visibility of all our software. And as we heard this morning, one of the ways we get Python to work faster is to use other languages with a nice API into Rust or C or whatever. Do we see that? We need an S-bomb. Good question. And I want you to think about a song that you might want to sing after the end. What's an S-bomb? You look at that cake. Can you tell me what's inside that cake? You want to eat it? Probably, yes. It could be anything. It could be flies in that. Yes. You could be allergic to some of the content in there. You don't know what the ingredients are. Why do you go to a restaurant? What's the first thing they say before you sit down is, are you allergic to anything? That's their risk process. Yes? What you want is you want fresh ingredients. You want ingredients that are from a valuable source, a trusted source. You want it so the risk to you as a consumer is as low as possible. Never no risk, but as low as possible. So when we're using software, are we asking those sort of questions? So do we have all the packages that we are using? Not just the ones the developers think they're using, the ones that they're really using. Do we have all those dependencies that are buried many levels deep? Are we using up-to-date software? Probably not. So how are you going to assess the risk? Have you got a vulnerability that's going to relieve a data exploit, a ransomware attack? Or are you breaching open source licenses? This is why PEP 770 comes in. It defines a standard way in your distribution of including this document called an SBOM, Software Bill of Materials. And it makes what's in your build visible. There's also PEP 751 as well, which talks about dependencies as well. But this is defining a standard format. SBOMs are a standard. They are increasingly needed. We'll talk about this in the next slide in a minute. But we want the security scanners to start looking inside and going deeper. Don't just look at the first level of dependencies, go all the way down. Why does this matter? We all want to do security and secure software. As a community, we must do that. Governments want their citizens to be safe and secure. Europe has got something called the Cyber Resilience Act. They require every digital product to have an SBOM. If you sell into Europe, you need one. We want our customers to trust our software. Having an SBOM is demonstrating you take security and development seriously. And I want transparency. To be more secure, you need to be more open, not closed. So what should you do? Start including SBOMs. Maintainers, developers, if you start procuring software, ask for an SBOM. And if they don't know what an SBOM, that's a good indication they don't know how to do software development. Why me? I live and breathe this. I'm part of the worldwide community. I'm part of the standards body defining the standards. I work with governments to try and define the standards to help make software more secure. The UK is a bit behind, but US, Australia, India, Europe are well ahead of this, but we all use global software. Go and have a look at my GitHub. I have some software.
Thank you, Anthony. Next we have Hugh Evans. When is a tractor not a tractor? When it turns into a barn. There aren't any better ones than that. They get worse. Hugh is going to tell us why Meetup is... Are you okay?
I'm having some interesting slides.
Oh, very exciting.
Maybe more tractor jokes, Mark.
I can't remember any more tractor jokes.
I was promised tractor jokes.
A farmer did drive past my house on a tractor the other day. A farmer did drive past my house on a tractor the other day, screaming about the end of the world. I think it was Farmageddon. I told you they got worse. You're allowed to boo me. You're not allowed to boo these people.
Thank you for that.
Okay,
Cheers, Mark.
take it away, Hugh.
Hi, I'm Hugh. I'm a developer advocate at Ivan, and for the past few years, I've been getting involved in community organising. Here are some of my favourite groups that I go to in London. This is far from an exclusive list, but they all happen for one reason or another to be hosted on Meetup. For those who aren't aware, it's a popular platform for event organising for in-person and virtual events. This would be great apart from one thing. Meetup is terrible now. It's so bad. Meetup is getting slower, it's getting buggier, it's getting more expensive to use, and as an attendee, it's pretty bad. But where it gets really bad is as an organizer. Costs have gone up, and technical issues cause key features like stats and custom domains to break regularly. I could spend much, much longer than 5 minutes complaining about Meetup, and believe me, I have done in the past, but rest assured there are a wealth of other issues with Meetup. Blogger and journalist Cory Doctorow coined a term for what's happening to platforms like Meetup that degrade in quality and let down their users over time. You may be familiar with it. Say it with me. Inshitification. So, Meetup is terrible now. What can we do about it? There are a number of alternatives to Meetup out there on the market. New players like Luma, School, and Odd Circles that are offering much better tooling, I think, although not necessarily any cheaper than Meetup, as well as more established platforms like Tito and Eventbrite, but they tend to be more focused on ticketing. Moving to a new platform could be a solution to how crap Meetup is now, but ultimately, all of these platforms are still privately owned, and they still run the same risk of enshittification as Meetup. What if we didn't need to move to a new platform, but instead built our own central site for attendees to register and link to it from other platforms? This would be a kind of variation of POSSE, Post-Owned Site Syndicate Everywhere, which has sort of been popularized by the indie web, which is an approach to sharing content online which promises to reduce dependence on third-party platforms. It helps you protect your ownership rights by keeping all your data in a central service that you own, and lets you spread your presence across multiple platforms through syndication, so the failure of one doesn't destroy your entire online presence. Particularly for smaller or solo teams, though, there's a lot of work up front in getting this working, which means it can't quite compete with the convenience of one central platform just yet. Can we do better than just moving platforms or reducing our reliance on a single platform, though? Oh yeah, I'll put animations in that, there you go. Yes, but only by working together. Collaboration with organizers of other communities is an extremely powerful way to both grow a community you're involved in organizing, but also to grow as an organizer. Primarily by avoiding reliance on network effects of established platforms like Meetup, by working with other communities to cross-promote events, we can cut out the platform entirely as a middleman. Collaboration can include co-hosting events, cross-promotion, and introducing potential speakers, sharing venues and sponsors and other resources. All of this is to say, strong in-person networks beat the network effects from event platforms for sustainable promotion, growth, and support in the long run, without you shilling out £500 a month for Meetup to lose all of your data from the last year. We've actually tried out a lot of these approaches at AI Signals, the community I'm involved in organizing in London. If you'd like to see some of the outcomes of this work, I'm writing up a blog about it at the minute, which should be available as soon as I finish writing it in the next couple of weeks when I'm not at a conference anymore. If you're interested in collaborating with other community organizers or are looking for support as an organizer, check out notanother.pizza. It's a Discord group. It's got a bunch of friendly organizers in it. We help each other out, primarily with things like venues and sponsors, but there's often a shoulder to cry on or someone to talk to about the often difficult job of organizing. Together, we can push for platforms, and not just event platforms, that give more and take less and don't succumb to enshittification the second there's money in it for them. Thanks for listening.
Thank you, Hugh. How many event organizers do we have here? Stick up your hands. So it could be quite interesting to get together maybe in a break tomorrow or the day after and have a conversation about the difficulties we all face, because pretty much agree, Meetup, it's not very good these days. And now it's my great pleasure to introduce Jyoti, who is going to give a talk about 5 common issues in research data management and how Hatch Python helps packaging descriptions.
Hi everyone, I'm really excited to be here and I'm having a great experience and hope you are having the same. My name is Jyoti Bhogal. I am the co-founder of RSC Asia Community and also an SSI Fellow 2025. Today I will be speaking about 5 common research data management issues and how to resolve them using Python packaging hash from PyPy. This work was done during VHI Discovery Internship Program, and I was mentored by Roland Mosbergen. You can scan through the QR code to get to my Linktree links, and please feel free to connect through socials. So I'll dive right into what research data management is. So research data management is the process of collecting, storing, organizing, and using data in a structured manner to ensure there's accuracy, completeness, and security. Essentially, it's about making sure that data is accessible, reliable, and used effectively to support operations and decision-making. However, there are quite a few pain points when it comes to research data management. Some of these are difficulty in managing the data when it comes from multiple organizations, There is also lack of effective management software. There can be limitations around storage and compute resources. There is difficulty in tracking the data sets when they belong to different organizations. And there's also another difficulty in creating one solution for multiple needs to cater to different projects and different data sets. So here comes RedMain as a solution. RedMain, as the name, as you can see on the screen, is Research Data Management and Analysis Environment. How it helps is by making data management software lighter. It helps researchers to keep a track of their data. It's cheaper to run, and it handles new data types easily, and it's easy and fast to import data. So on the screen, you can see a high-level structure of RedMain. At the top level, there is a common patient ID, sample ID for different data sets. The whole system includes a variety of data sets, including whole genome sequence, tabular data set, imaging data set, and many other types. So during this project, I worked on specifically on WGS data sets. And also because this is genomic data for cancer, I could not access real-world data and put it out in an open-source GitHub repository, which is why I had to generate data synthetically to create the data workflow. So here's a maturity model for how WGS data workflow would go. So the first step is to create empty files with correct file names. For the workflow. Then the next step is to generate and add a minimal sample data to these empty files, followed by adding some more sample data to the minimal files, and finally creating and uploading the metadata to cBioportal. So cBioportal is an open source platform where we can upload data that's related to genomics and specifically cancer research. So these are the steps. I wouldn't go into this into detail, but however, I have a blog post where you can read all the details. So if you scan the QR code, you will be able to go to the GitHub link for an R package, generate RViz, which I created for this purpose. And the blog post links are also available there and also on my website. So the next step would be to create a Python package using hash from PyPy. And over there is the link. If you are interested, you can check it out. And thank you very much for listening.
Thank you, Jyoti. Okay, we're doing a very good job. Keep on moving. Now we have Data on a Click by Perla. Perla? Excellent. Take it away.
Yeah. So, thanks. It just started as a joke with my last boss. So I was talking about how to create clean data. And after that, I've just had a brilliant idea. It's not really brilliant, but I had an idea. I was like, why not we use a click package? It's a Python package, obviously, which used decorators and had a lot of documentation. So here, well, I've worked at the Ministry of Missing People at Mexico City, so I got numbers. Over 1 million people are missing globally, enough to fill 10 football stadiums. Clean data, help us see them. So next, messy data is everywhere. I think there are many troubles. You've been there. So why I choose to work with Click, it's because there are many JSONs with inconsistent keys, Excel sheets with missing columns, and multiple formats, and thousands of records. So before I was like writing import sys, files, sysarg, and things like that. So it has no validation, no help, and errors everywhere. That's my everyday life. So I only could run it, but I need to bring many other people that works at the Missing People Ministry. So I need to improve the skills and putting more people to work on it. So with Click, we have declarative options, automatic help, type validations, prompts, and default values. So it's beautifully organized. So this made my script usable for anyone. So with just 4 lines of code, I could run and clean the messed up data. So for example, with a dirty data, we have mixed cases, extra spaces, missing values, and 100 of records, 1,000 of records from public data before cleaned manually. Now we can run it with 1 command in 1 second. So I'm not gonna really go in that, but there are many tools, but I've just started like, why not to prove any other tools? So the result is that Click has declarative validations, clear validation, and reusable decorators. So from chaos to clarity, and I avoid to put a video demo because I just wrote it down a minute ago. Yeah, but you could just run it like with Python, your script, clean py, input, dirty JSON, so you could give XLSX file for people who are not programmers. So the impact, working with public global data about missing people, built internal tools to automate the cleaning and reporting processes. So using Click, I created a CLI that non-programmers could run. So it helps us visualize critical information in Redash, which is a tool based on Flask and Python. So again, I could be help for non-programmers, and they just drag and drop the graphics and things like that. And of course, it saves us hours of manual work and ensure consistency across data sets. So clean, accessible data is not just about numbers, it's about visibility. Thanks.
Thank you, Perla. Are we still stamping our feet? Can I hear you stamping your feet? Brilliant. And you can stick some clapping in there as well. We're 2/3 of the way through. It's a very dark, warm room, so keep the energy up. And now we have Alex, who is going to talk about repeatable compression.
Hello everyone, my name's Alex and I've been playing with compression. Seems an odd toy, but it keeps me amused. So, a quick refresher. Lossless compression. You take a big thing, it makes a small thing. But critically, you take that small thing and you can undo it to get the big thing again. So dev null is not compression, even though it does really make things small. Now, that's what compression guarantees. What it doesn't guarantee is that when you compress your big thing to a small thing, would you get the same small thing every time? No. But it would be good if you could. So that's what I've been trying to do. So as an example, apologies if you can't read that. This was done in a bit of a rush. Python 3.14 release candidate 2 came out a few months ago. RC3 came out yesterday, but this is what I had. And it's shipped as a .tar.xz file. XZ is a particular compression format. It gives you smaller files, but it takes longer to do it. And when the person that created RC2 compressed it, the output they got was 22 megabytes, and it had a SHA-256 sum of that long string there. Now, we can decompress this file, and we get just a plain tar. And it is the same tar that the person that produced RC2 had on their disk. That's what the guarantee is. But if we make our own XZ file, and we will just call ours .xz2 just to distinguish it, and you see we get a completely different SHA-256 sum. Now, what can we do about that? For XZ files, not a great deal yet, because I'm still working on them. But if you want a gzip file, I can do a lot better for you. So, the problem is that things are creeping in that alter the output of the compression. And there are various sources of these. People that do reproducible builds will recognize a lot of items on this list. We're not trying to do reproducible builds here. Someone's already done the build for us. We just want to do the compression again. The major source of things that causes these SHA-256 sum differences in the compression is the options and the metadata. So the person that compressed it, they might have used the absolute best level. They spent extra hard time on it because it's going to be downloaded thousands of times. So it makes sense to spend an extra minute once to get a few bytes saved, downloaded 1,000 or 1,000,000 times. We don't know what they used. We can make some guesses, and we can try a few of those guesses and see if they match up. That's the idea. Now, hopefully, the demo will work. So, what we have here is the RC2 tar.xz as produced by the release manager for 3.14, a particular SHA-256 sum. It'll take a little while to read. Oh, thank you. Demo gods, I implore thee. So, SHA-256 sum. We're not going to be able to get that out yet, but maybe we can do something for gzip files. So, second demo. What we have here is the decompressed tar file that was in that XZ file, and then we've compressed it 3 times with gzip. And each of these files is ever so slightly different, even though if you decompressed them, the output would be identical. So if we have a look at the SHA-256 sum, SHA-256 sum of these, no, we're already in that directory. So, 3 files, they're roughly the same size, they were all compressed with a version of gzip, but they're all different. Why is that? Well, if we have a look at the default one, which was just produced with gzip that shipped on this laptop, it's some version of gzip, probably not GNU, because Apple don't like that. But there is a nice utility we can use called infgen, which lets you see the internals of a gzip file. And if we run that on the default, we see that when we produce this file, we got a little bit more than just a file. We also got the modification time of the original file on disk.
You are running out of time now, Alex. I
and the
don't want to
original-
cut you off in the
okay.
middle of a demo, but
So I will do one more command, then I will conclude. If we run the same command on no name, which was compressed with gzip-9, and we remember to pipe it into head,
it's the risk you take.
please Google GitHub blob to blob to see the project. Thank you.
Thank you, Alex. So now we have tomorrow's keynote speaker, Sheena. It's tomorrow? Sunday's keynote speaker, Sheena. Who is, and I lost my place. See, this is the problem. There we go. Who's going to be talking about Python in Africa.
Awesome. Hello, everybody. So, where is this? The Burmese python is an invasive species in Africa. Okay, so I have a question. How many of you have been to Africa? Okay, that's actually a surprising amount. How many of you want to go to Africa but haven't been yet? Okay, cool. There's always a lot of hands. So I have a question. Why? Why do you want to go there? Is it because of the wildlife, the landscape, the culture, the food? Yes? Okay, how about for the python? There are a lot of Python communities in Africa that are very much worth visiting. So, hello from Africa. It might not be immediately obvious, but I am an African. I have been living in South Africa for my whole life. My family's been there for multiple generations. Came a long way to come here. And there are other Africans in the room as well. I've seen a few faces that I recognize. So I haven't been to all of the African Python conferences. Africa's a very, very big place, and I live right on the pointy end at the bottom of the continent. But I've been to a few. And the experience has been pretty varied, but quite special. So first of all, there's PYCON South Africa, PYCON ZA, that happens in South Africa every year. I've been a part of that for quite some time. PYCON Namibia is a very special one. I heard a woo. Who's been to PYCON Namibia? Yes, yes. It's fantastic. It's a very different feeling from PYCON South Africa. It's a thing that Namibia needs, I think. DjangoCon Africa. Who's been to DjangoCon Africa? Yes. Okay, not a lot of people. 2 years ago, it was in Zanzibar, which was fantastic, and this year it was in Arusha. Finally, PyCon Africa. So PyCon Africa is happening in South Africa this year. And there's a lot more that I haven't been to. There are many that I'd like to go to. I'd like to go to Zimbabwe, for example. Their experience is always different. So there are some things that are similar across the board. So whenever I go to an African Python conference, I meet a lot of people who are solid and passionate and skilled and solving local problems in local ways. There are people making new languages that are based on their home languages and people solving infrastructure problems in Africa because there are challenges. The community is growing. Africa is a young continent. There are a lot of young people there. There are a lot of junior level skills. And so there's a lot of inspiration, there's a lot of hunger for knowledge. It's very hard to go to an African conference and not be just peppered with a lot of questions. So it's exciting because you can actually make a difference and you can plant some real seeds. It's resource constrained, and that can seem like a downside, but actually it's pretty cool in a way because those constraints lead to creativity and they lead to stronger bonds between people. You can't just pay to make your problems go away. You actually have to make a plan with humans. So it's kind of beautiful. So if you are keen to go to Africa, get involved in some way. Stay in the loop about what is happening in Africa, follow along on African social media channels and see when the conferences are happening. Go to one if you can. It's a much richer experience than just being a tourist. And you can watch the talks online as well. So if you want to know more, PyCon Africa is happening pretty soon, and you can just Google it and follow the socials. And from that account, you'll be able to stay in the loop on different African conferences. Thank you.
Thank you, Sheena. So despite the fact that we set up a laptop here, that is going to be our last talk of the evening. So can we have a massive round of applause for all of our speakers this evening? We had 4 new speakers. Can we have a big round of applause for the 4 new speakers? Congratulations. Okay, so that's the end of the main syllabus for the day. There is still the Ada play read-through at 6:30 in space 2. For people who want to hang around for that, the bar is also open, and I think it's going to be serving pizza. Could I get a nod or a shake from somebody who knows the answer? That was a thumbs up, yes. So other than that, we will be doing lightning talks tomorrow afternoon as well. So don't forget, the buckets will be by the front desk if you have had sudden inspiration